A famous reasoning AI beats its ordinary sibling by about 19 points on one science test, then loses to that same sibling by about 25 points on another test of the exact same skill.
Wait, same two models, opposite winners? So which one's actually smarter?
That's the whole puzzle. So here's your guess for the road. Out of every 10 times reasoning mode made a model better, how many do you think were the model actually thinking harder? Hold that number. And keep an eye on one odd couple of homework problems, one about gas squeezed in a container and one about acid in a beaker. That pair is how the researchers caught what was really going on.
Okay, set it up for me.
A test built like a science experiment, a switch you can flip on a single AI, reasoning on, reasoning off, and a bill for the whole thing that came in under $1,000. And it matters, because every time you ask an AI to check your math or walk through a physics problem, there's a pricier, reasoning version companies say thinks harder. This paper, published July 1st, 2026, asks whether you're paying for thinking or for something else.
I mean, that part feels obvious. It stops, works through the steps, shows it's thinking. Of course it does better.
That's what everyone assumed. Then someone built a test to check, and the extra thinking mostly wasn't thinking. Picture two exam questions built as perfect twins. 1. A gas at 300 Kelvin in a container, find the pressure. Its twin. A weak acid in water, find the pH. Totally different science, but the steps are identical. Recall the right formula, plug in the numbers, and compute. Same moves, zero shared facts.
And those twins are the trick. How?
Because now you can run something clean. Flip a model into reasoning mode. If it improves, watch where the improvement lands. If better thinking is what happened, it should help on both twins. They share nothing but their logic. If it only helps on one, the model didn't get smarter. It just remembered that one subject's fact.
A cheat sheet, not a skill.
Exactly that. So they built a big set of these twin pairs across 4 science subjects, ran them through 5 different AIs, and counted. And the cleanest test, keep this one in mind, was flipping reasoning on and off inside the very same model, same everything, just the switch.
So what did the counting say?
Out of every improvement reasoning mode delivered, more than 9 in 10 landed on only one twin.
9 in 10? So almost all of it was just memory?
Almost all of it. And that switch test sealed it. Flip reasoning on inside one model, and it helped about as often as it hurt. A coin flip. Remember the number you were holding. How many of 10 were real thinking? Fewer than 1. And that gas and acid pair is the whole story in miniature. On a test full of facts the model already knows, longer reasoning fishes them up and it looks brilliant. On a test leaning on facts it doesn't have, the same reasoning fishes up nothing, and it sinks. It's like asking whether a sprinter or a marathoner is the better runner. Depends entirely which race you make them run.
Though, one honest catch. They only tested short, quick problems, 3 to 5 steps. This doesn't say reasoning is useless on the long, gnarly stuff. On a hard 20-step proof, all that thinking might really earn its price. Nobody's checked that yet.
Fair. On the quick science most of us actually use it for, the pricey thinking bought almost nothing.
So, here's yours to argue. If 2 fair tests can crown opposite winners, would you trust an AI leaderboard less? Or just start asking, better at what?
And if you like research pulled apart like this, subscribe and join a growing crowd who'd rather understand the studies than the headlines. Watch the next big reasoning release. The day it finally helps on both twins at once is the day that switch starts thinking. Until then, it's just remembering.